But like I said, this molecular formula stuff, in order to calculate the molecular formula, you need to know the empirical formula. Empirical formula is what we did yesterday. So what I would like for you to do, first of all, is find the empirical formula for this problem right here. So find the empirical formula, and then we will go on further to work the molecular formula. Okay, as I went through and we calculated, and I did my calculations, let me go back up here. Okay, I came up to, whoa, that box out of there. Right here, I came up and calculated my empirical formula to be C2H4O. Okay, that was review of yesterday's material. Okay, would we agree with those values? Great. I didn't think I made any mistakes here, but it could happen. So now I have my empirical formula. What do I do with it? What do I do with it? Well, I come back into my question and I see that the molecular weight is 176 grams per mole. That's going to be important coming up, because what I need to do now is to calculate the weight of my empirical formula. So, carbon, there are two of them. Each one is 12.011. So that's going to be 24.022. Hydrogen is 4 times 1.0079. So that's going to give me 4.0316. Oxygen is 1 at 15.9994. So I come up with the mass of 44.053 grams per mole. That is the mass of my empirical formula. Now, to determine my molecular formula. To determine my molecular formula, I look back in the problem and see that 176 there. So I say, okay, 176 grams per mole is the molecular. The empirical is 44.053 grams per mole. So how many times is that? 176 divided by 44.53, and I get 3.995, which is going to tell me 4. So my empirical formula times 4 will give me my molecular formula. Well, I look back up here, and it's C2H4O. So if I am going to multiply each one of those by 4, I am going to get C8H16O4. So that is my molecular formula for this problem. Now, once again, just like with empirical formula, these things are usually pretty well thought out. If you get some random number that doesn't multiply to an even number, okay? That doesn't multiply to an even number. And what I mean is if you get 1.5, that's fine. You multiply that by 3. If you get 1.33, that's fine. You multiply that and you can get those into whole numbers. But if you would get, something crazy like, 1.85, you might want to go back and look and say, okay, I'm going to double check because Mr. Braun says these usually work out pretty good. So I'm going to double check my numbers to make sure I didn't make a calculator error or some error reading periodic table. I don't know. Here is my second problem. Go ahead and copy it down. Okay, I've calculated now my empirical formula to be C3H2O. Oh, it should be Cl? Yeah, good point. That might have been a problem. Cl, my bad. C3H2Cl. Now, what I need to do to get my empirical formula into a molecular formula, I need to go back through and calculate the mass of that empirical formula. So, carbon is 12.011. I have 3 of them. So that's going to give me 36.33. Hydrogen, 2 of the 1.0079. And I came up with 73.4988. Would we agree on that value? So I'm not finished now. I need to go back. And I was given the value of 150 grams per mole of the molecular formula, 73.4988 for the empirical. That gives me 2.04, which is, I am going to say is 2. So as I go back, it's going to be C6H4Cl2. It's a Credruck 2. Cl2. What do you think? Get them nice and high. Can we give me a thumbs up here? Okay. Excellent.